Hello, my name is Billy Moran. I'm the Marketing Director for AppLogics, and I'd like to thank you for coming to our Cisco Live follow-up webinar. We really had a great time out in San Diego about a month ago. We had a lot of good conversations at our booth with both current customers and people learning for the first time about AppLogics and local management. There's one of them now. John Chambers came by the booth, or at least close to it, and we appreciate that. We are a Cisco development partner, and we appreciate John coming by. So today we're really brief. We're trying to respect everybody's time. We're going to jump right into things. A few housekeeping things to keep in mind. If you do have some questions, hopefully you came with some from the show, or will inspire some today during the presentations. If you can go ahead and submit them through the chat feature, or if you want to hang on to them, we'll unmute everybody's phone at the end, and you can ask them then. Jumping forward to kind of the next steps after this, we will make the recording of the webinar available in the presentations. If you need to forward them on, somebody couldn't be here today, that's great. And then hopefully this will lead on to more conversation. We'd love to be able to ask you more questions and find out about your needs and your network. And then down the line we have an established proof of concept program where generally we say, give us your toughest problems, your hardest sites, and we'll show you what we can do for you. So today, we're going to hear from two people. We're going to hear from Martta Howard. She's our Technical Services Manager, and she's going to be giving kind of some background on local management and how it works. And then we're going to go to James Dollar, who started AppLogics since our CTO, and he's going to be showing you kind of the day in the life of an AppLogics deployment. So without further ado, we're going to jump right in. Here's Martta.
Welcome, everybody. I'm so glad you could join us today. I know that when we were out at Cisco Live, I'm sure everybody saw a ton of stuff. So just a quick refresher on what is this whole local management concept and what is AppLogics. So AppLogics is a local network management platform. And what that means is we are physically located in the exact same rack with the gear that we're managing. We are connected via a dedicated piece of copper, Cat5, to the console of each of the pieces of equipment that we're managing, such as that router, that firewall, that switch, that server that you see there. We complement your existing network management solutions by providing a very rich set of data at the very edge, at the very remote of your network. So what does that rack really look like? You can see we've got those console connections. Because we're going over the console, we can pull very frequently without having any tax on your network. So by default, we go every 30 seconds and check the state of the equipment, collect key parameters about what's going on, the health of your remote site there. And you can see that we're also integrated with Smart Power. And then you see our AppLogics local manager there at the bottom of that rack. And what that is that's our piece of equipment that lives with your remote site, and we've got all of our built-in intelligence, our automation, everything is there right next to the stuff that we're managing. So what does that look like in your remote site? So let's just pull that out. Maybe this is in your branch office in Singapore. Maybe you've got your AppLogics local manager in your data center that's across the street, that's in your colo. Everybody has a different definition of remote site, but it's basically where you are not. What we do is we connect those local and those remote sites back into your NOC and report into our AppLogics control center, which stays in your NOC. So what are we doing for you there when your network is up and green and everything's happy, all of your centralized management tools are saying everything's great and green across all your dashboards? What we're doing there on the remote side is we are helping to manage your configuration. So every piece of equipment that we're connected to, we are pulling down its configuration and we're storing it locally. And in fact, we'll store up to 27 different versions of that configuration and keep that locally. We'll also pull down, again, that key parameter data and keep that local for you. As things are going on your equipment, we're comprehensively logging and keeping track of every keystroke that's coming across that console. So whether it's something that a user types in or it's something that the device itself spits out, we're going to capture that in our log and keep that locally. Now, we will tie into your TACX and Radius servers back in your NOC, and we do have a very granular role-based administration system. So for instance, let's say you have a firewall team and you only want them to be able to access the firewalls. What we can do is we can create a role that defines that group and grant them the permissions to have all the administrative rights on the firewall, but not even see anything else that's at that remote site. Or say, for instance, you have a level 1 tech. You want them to be able to investigate if there is something going on, but you don't want them taking any actions. Every single command on the Uplogix is permissionable, so we can create a role that's tailored to the specific environment in your company. And finally, again, I talked about that polling every 30 seconds. What we're doing is we're collecting key pieces of data, the information that you would have and you would search for if you were directly connected over the console to that equipment. We are pulling down more detailed information than you would normally if you were going over SNMP, simply because since we're not taxing the network, we might as well collect it for you, and then it's there at your fingertips should you need it. Now, what happens when your network is having an issue, when your dashboards start going red or yellow? We still have those configurations available to you. So let's say, for instance, you are updating some information on that router at that remote site, and you just happen to accidentally fat finger something and you saw off the branch that you're standing on. Well, normally that's a huge problem, right? Normally you would have to pick up the phone and actually call someone to help you out of the situation, but not with the Uplogix. With the Uplogix, we recognize that the terminal session that you're in working on that router has 0 activity, and we automatically close it out. We will then look at the configuration and compare it against the configuration that we pulled just prior to you going into a terminal session with that router, and we will recognize that there are differences. And what we'll do is we will ask you to commit the changes that you made during your session. Now, obviously, you are off going and getting a cup of coffee because you are not there to commit those changes. And we'll put a little countdown clock on it. We'll count down, and once that countdown's over and you haven't committed those changes, we will line by line surgically roll back all the changes that you made. So by the time you get back to your desk from getting that cup of coffee, you've got that access to that router again. You can go back in and make the changes that you had intended to make. Now, because we're storing both the configuration as well as up to 3 versions of the operating system locally for each device, we can also help you in a situation when the router is down completely. So say, for instance, your router dies and you have to send a new one to the site. Don't bother to send a tech. As long as you have a person there who can handle the layer 1 stuff, the actual physical cabling, throw it into the rack, plug the cables into the exact same place they were before, the AppLogics is going to query that router. We're going to recognize that we're missing a configuration. We're going to recognize that maybe even the OS is different than the one that we had stored locally. And we're also going to recognize that the serial number is different. And we're going to realize, hey, a change has been made. And we're going to automatically push out the last known good configuration, push out the last known good operating system, and before you even know it, that router is back up to where you were before its predecessor died. Now, you'll see in this situation, we've drawn an extra line here, and we've called it the secure out-of-band link. What happens when your primary network goes down is the Uplogix will automatically spin up an out-of-band connection. And that out-of-band connection can be anything from a POTS line, if you happen to have one available, say if you're in a data center setting, to a cellular modem if you've got good cell coverage, or even something as extreme as an Iridium connection or some other satellite link connection back to your NOC. And what we'll do is we'll reconnect back to your TACX, to your Radius servers. So if somebody needs to come in over that out-of-band link, they're not going to use a break glass password. We're going to force them to use their secure password. We're going to continue to log every keystroke that's made, so you don't ever have to wonder, what did Bob do to fix that site during that outage? Because the Uplogix is recording everything that's going on in his session log. And finally, I talked a little bit about the intelligence of the Uplogix Local Manager. We do have automation built in. We've got scripts built in already. We've got the runbook for Cisco TAC already coded into our product so that we can recognize known error states and automatically take actions to repair them for you, just like if you had a level 1 tech on site. But say for instance you've got some equipment out there where you want to take some specific actions that are tailored exactly to how your runbook would go. What we do is we give you access to a flexible rules engine so that you can actually go in and write rules yourself, so that the Uplogix Manager will behave exactly as you want it to. You can train that local manager to take the same actions that you would take in an outage or you would take in an error situation. The other thing that offers you is the ability to learn new equipment, to be able to pretty much interact with anything on your network in exactly the manner that you would like based on your company policies. So with that, I think I'm going to turn it over to James to give you an idea of a couple examples, a couple use cases, and a few day-in-the-life snapshots.
Thanks. Yeah. So let's talk about a couple of the mechanics behind what Marta described. As we were talking earlier, we're polling every 30 seconds, and so we collect a great deal of data about those devices. The same kind of data that SNMP queries, we're just querying it all over the console ports. And because we do, we don't deter the device from being able to switch packets, and we don't really generate any network traffic for that. So it's a very efficient way to collect data about RX bytes, TX bytes, and all those SNMP variables that you get today. We just do it over the console port. And because we put it in a local database, we don't need any networking to be available. Even our out-of-band system doesn't need to be up to be able to collect data and put it in a local database. And then we use that data by passing it through a rules engine. Every time we collect data, we look at the rules engine again and say, what have we learned about this system that we didn't know a minute ago? And we'll take you through an example of that in just a minute of detecting and starting to react from a network outage. And then if nothing passes our threshold in the rules engine, we just continue monitoring. And so 99.9% of the time, we're just continuing to poll, looking at the data, seeing it doesn't exceed any threshold, and go back to monitoring. Now, you generally still have your network, your core network monitoring systems, your SolarWinds and your Tivolis and CA Spectrums and products like that polling over the wide area network. It's just generally much less frequent than our system. So as we're polling every 30 seconds, we might detect that a T1 connection on that router went down. In fact, we were running a show interface or a show service module command, and we see that our frame loss seconds incremented, our protocol state is up, but the operational state is down. Sorry, the operational state is up, but the protocol state is down. And so we might collect that information in the first 30 seconds that there's an issue, but we might not want to take an action all that quickly. So we might wait just a couple of seconds, and so we'll poll again 30 seconds later. We may see this same state again, and so then we have two instances of it, and we're starting to put together a contiguous problem. So 30 seconds later, let's say we poll again, we see it again, so we have three instances, two more times. In 2.5 minutes of this outage, we'll have 5 samples of it being a problem, and generally at that point we start taking automated first-level actions. The same stuff Cisco TAC would take you through if you'd called them and said, hey, I've got a frame loss seconds incrementing and an up-down state. So if you followed Cisco TAC or built your own, their first recommendation is to run the clear service module command against that. And so that's what the Uplogix appliance is designed to do, is to collect that data, triangulate it locally, and then take that first level action. If that solves the problem, which it does 10% of the time, we're back to monitoring and business as usual, and the network's back up within about 2.5 minutes. If that didn't solve the problem, then we'll take the next first level action. Cisco TAC recommends, or as Marta mentioned, you can add your own. Shut the port. See if that brings the connection back up. If that does solve the problem, then you're done in about 3.5 minutes from the time that the problem began. If it doesn't, you take the next first level action. pull the show tech and store it away with all the low-level control information. So if you have to open a attack case, you have it from the middle of the outage. It generally takes about a minute to execute that step, but by the time that that's complete, you would follow on to the next Cisco attack recommended best practice of doing a reboot. But before you do steps like reboot and power cycle, those low-level steps that often resolve problems, you need to make sure that the network tests, or that the network is not meeting its minimum service levels. And so we run synthetic tests over the network from that remote perspective. And one of the first ones that we might be running there is a voice over IP test, maybe a call between the UpLogix local manager that's in the rack and another UpLogix local manager across the network somewhere. And we want to see that from the voice VLAN that calls are not succeeding. And we use that to gate our automation in this case. And so as we look across the database at our tests, we see our voice calls are failing. We might also look at synthetic web transactions, maybe to an intranet site or to Google, just to validate that the network web page loaders are failing. This is, again, a gate of our automation, but it's also the ability to validate that those service levels are not being met. We might do another test that is just a TCP SYNAC round trip to some ERP application or some other application on your network. Again, it's another way that we validate that the business use of the network is failing at the remote site. Not only do we see loss of frame incrementing, operational state up down, but we also see these synthetic tests are failing. So it gives us more confidence to take broader level action. So if all those things are true, we're about 5.5 minutes into the outage. We take the reboot action because we've validated, again, that all those other network components are down. And if that solves the problem, we're done in about 6 minutes. We come back up, we query again. We're still having the exact same state, and so we take a power cycle action by switching off that outlet with that power distribution unit over to the right. So in this case, that solved the problem. We're back to up and up, and the lost seconds are cleared, and we're back to business as usual. From the time the first packet dropped to the time the resolution is about 8.5 minutes. That's really the remote's automation perspective of this of our product. But we also have a component that lives at the NOC called our control center, and we'll look at it from the control center's viewpoint. Those tools at the NOC, let's say it's CA Spectrum that you're using, are polling over the network as long as the network is up. But when the network goes down, that poll will show up inside Spectrum with devices not responding. You don't know what the problem is. It could be a backhoe, it could be an access control list, it could be a power problem. But basically, that's what your NOC provides for you today. And what the AppLogics appliance is designed to do by default is bring up an out-of-band connection from the remote back into the NOC after about 2.5 minutes of not being able to communicate. And it does that by doing a dial-up connection over cellular or analog dial tone, connecting back to the NOC, maybe building a VPN back in, and connecting to the control center. And then the control center has the ability to take those status messages from the local manager and backfill CA Spectrum and Tivoli and SolarWinds and all those products with the remote's perspective of the problem. So the first thing that we would see in our Spectrum dashboard, for example, would be those top two lines are what Spectrum generated, and what you see in the orange lines are what the AppLogics is doing about it. And so in our example earlier, the first thing that we noticed is that we have frame loss seconds incrementing in the protocol states down. So that's first of all going to be associated with that router in Spectrum, increasing the visibility and usefulness of that product in the middle of the outage. And the next thing you start seeing are the automated actions that the AppLogics is starting to take. The clear service module starting completed, the interface cycle, the show tech, the reboot, and the power cycle commands are all backfilled as they occur back into the graphical interface of the of CA Spectrum to let you know what the remote is doing, as well as to see current up to the minute state of the network. And in this case, after that power cycle, the in-band SNMP queries start to complete, and those systems go green again, and we're back to business as usual. We'll talk a little bit about that service level verification just to let you know how that's working. We're doing synthetic tests over the network to both give you a baseline of availability, but also, as I mentioned, to gate our automation. If we saw those loss of frame or interface state up-down messages, they generally wouldn't be enough to want to trigger an automated power cycle. But once we fail some of those business level tests, as we were saying, that's the assurance that you need, and the same kind of assurance that a first level tech would use to validate that it's okay to take actions like power cycle. In our voice test, we're doing basically a call across the network, just like when the Verizon guy says, can you hear me now? We're actually running real voices using your codecs over your network from point A to point B to validate that ability to make voice calls. Or, as I mentioned, simulated web transactions with DNS lookup and time to first and last byte and result code. All of those data points are used to help us and make that decision about the ability of the network to perform its tasks, or just that simple synthetic SYNAC round trip to prove TCP is up between point A and point B. So in this case, we would use the same routers and switches that the phone uses, and as it moves into its switch, its router, its WAN connection, back to another router and switch, we're looking at the layer 2 interfaces, bytes in and out. Maybe we're on our voice VLAN, and so we're looking at traffic and protocol status and load and really those things about layer 2 connectivity that make that call work. That's what we're doing by querying the router and switch directly. But then we do these calls and these transactions from the AppLogics appliance, from one AppLogics to another, and we're looking at layer 4 data. For example, in that voice call, we're looking at the RTCP values that come back from a voice call, and everything from jitter and latency and MOS scores and R values and drop packets, and all of those artifacts from the voice scoring go into our database right along with that layer 2 traffic, and we use all that together to make these decisions, which is really what our rules engine is designed to do, is decide and make decisions just like your first level techs would. Finally, this solution is really applicable across industries. Everyone has IP networking challenges and operational support challenges. These are some of the customers that have implemented AppLogics and use it in their operational networks as a core to their functionality today. What makes AppLogics different? Just to sum it up, we're always directly connected, right? Like SNMP, we get the same data, but we get it when the networks are down, which is really when you need this functionality. And then we poll very intensively at about 10 times the frequency of most network monitoring tools. We're a fail-safe safety net for making changes. Really, regardless of the change you make, we have the ability to recover from it, whether it's in the middle of a change window or if you're doing troubleshooting. In the middle of a live production network, we give you that ability to recover from finger fumbles and other diagnostics tests. We have a very flexible system of automation. We package best practice rule sets, give you the ability to tweak it, reorder it, retime it, really meet your operational posture for recovering from problems. We have a very granular roles-based management system that lets just the right people be able to do the right actions on the right devices, and then for systems that they don't have access to via permission, you can mask that. And then really we complement those existing tools like SolarWinds and Spectrum and Tivoli and those products by backfilling them in the time that they aren't actually able to do the querying across the network. All right, that's our presentations. We did have a few questions come in.
just a reminder, you can, if you're feeling shy, you can use the chat feature, and we can read them off there, or we'll unmute the lines in just a minute. The first question we had was about the rules engine. It says, what is the interface for the rules engine?
Right. So the interface is a action, condition action interface. So it looks at conditions across different data that we collected. So, for example, in the service level verification test we talked about a minute ago, it looks at the voice call and says, did the call complete? Yes or no, and it'll use that to take the next step. Or was the MOS score greater than 2? Or did I drop more than 10% of my packets? Or it might look at an RX interface on a T1 and say, did RX bytes increment? Do I see the loss of frame counter incrementing? Is the interface up, down? And those are the things that the condition is that. And then sometimes it can be over time. It can be the condition is RX bytes have not incremented for more than 5 minutes, or in calculation with another attribute like RX bytes haven't incremented but TX bytes have. And then we use that to determine the next action. Maybe it's just send an alarm or alert message to your Spectrum or SolarWinds console. Maybe it's send an email message to someone. Maybe it's to take one of the actions that we mentioned, like no shutting ports, clearing service modules, restoring last known good configurations.
Okay. This one says, I'm a voice guy. How does this help in the migration from TDM to voice over IP?
Yeah, so as you imagine, different groups generally coming together for that. In an enterprise, maybe they're just starting to hook TDM switches directly into routers and do tool bypass, and kind of, or maybe the voice and the data teams are having to work together. Often there's gaps in understanding of those systems, and so a system like Uplogix can provide the voice team with access to and maybe some information about those synthetic calls, proving a call from point A to point B should be working, as well as looking at some of the interfaces they're not used to being able to see, like that PRI interface on the router that they're connected to, just enough to reduce finger pointing, around the network. And really the same for the network side, is you're always proving that it's not the network. That's the problem. And these synthetic tests and this data that we collect are all part of validating that the network backbone is operational and meeting its SLA.
All right. So we just unmuted everybody, so if anybody wants to pipe up with a question live, you can do it now. Otherwise, we have another one off the chat. It was, what are the hardware options available? We're actually
have that somewhere.
We're prepared for this one.
I'm glad we made you put that one in backup.
Yeah, so we have the Uplogix 3200 is our scalable architecture that does from 8 to 32 ports. So 8 devices to 32 devices. It's one rack queue, and it comes in a 2-slot or 1-slot option. You can buy the 8 ports and then replace them with 16, and you can grow that way. And we also have our 430 appliance, which is fixed 4 ports and no moving parts. Fits great in a wiring closet or a janitor closet or wherever you happen to have IT gear. Good branch office product. And then we're also able to run as on the SREV blade inside of a ISR G2 Cisco router, either the 710 or 700 or 900 series blade. And again, that's run in VMware, and then we run as a process inside the router, connect through the MGF back around to async HWIC cards, and then fan out to the different devices that way. Again, all of our management happens over console connections to these devices, all out of band, so that we don't depend on the network to manage the network. And then we have a control center component, which is either we ship it on a Dell 720 chassis as a purpose-built appliance, or we can do that as a VMware appliance as well.
All right, James, I think you just answered this one, but it was, if you have multiple Uplogix devices throughout the network, is there an application to manage or view them centrally? Absolutely. Or do you access each of them independently?
You can do either, but absolutely.
Yes and yes.
Yeah.
You can use that Uplogix Control Center to actually view great big groups of your local managers. So say, for instance, you want to push a configuration snippet to a bunch of devices only in North America. You can create a filter to push that using the control center. You can view the state of multiple AppLogics local managers at once, check alarms, say in certain regions of the country, or however you'd like to slice it, like I want to see my data centers only. You can use that AppLogics control center to do that. But you can also log into each local manager independently. They're not required. You can function, they can function independent of each other, the control center and the local managers.
All right. So we want to keep this short. If there aren't any other questions on the phone, last chance. All right, we're going to call that a day. So we'll be in touch. Thank you very much for coming, and we'll talk to you soon.
Thank you.